This meeting is being recorded.
In problem 13 from chapter 21, we're asked to identify the reagents that can be used to perform these transformations shown. So what I've done is I've taken the question and you're given the starting material over here in this column, and then you're given the final product over here in this row here. So what we'll do is we'll walk through each of the intermediates, each of the steps that we need to take to accomplish these transformations. So in part A here, we see that we have this alcohol, and we know that we need to get to an ester. So somewhere in between, if we were to generate, say, this carboxylic acid here, we could react that with an alcohol and then generate this ester. So let's see how we can get there. We can use a strong oxidizing agent such as sodium dichromate and sulfuric acid, and water, we know, always goes with that, to generate this ketone intermediate shown here. Then at that point, we can react that ketone with the haloform reagents, since it is a methyl ketone, to create this carboxylic acid shown. So if you recall, that happens in two steps. So first we react molecular bromine with base, so sodium hydroxide, and then in our step 2, we'll add an acid workup here, so hydronium. Then that converts, as I mentioned before, to this carboxylic acid shown over here with this arrow. Then at that point, we can react, as I noted earlier, in this Fischer esterification reaction, our carboxylic acid with an alcohol. So in this case, we also need acidic conditions. So very similar to the lab that we performed when we did our own Fischer esterification. We used acetic acid and ethanol to create ethyl acetate. But instead, we'll use this carboxylic acid over here with ethanol to generate this ester. Okay, so let's take a look at parts B through D. I'll move a little bit quicker now that we kind of have the flow of things down. So in this first step here, we need to install an oxygen here. So an easy way to do that is through ozonolysis. So we'll cleave this bond, we'll lose this carbon here, and then we'll install this oxygen. So if you recall, we use ozone, and then in step 1, and then we can use dimethyl sulfide in a second step here. And those combinations of reagents will generate this ketone intermediate shown here. Then we can react this ketone with the same reagents as in step 1 to generate the same intermediate shown over here. So we'll use our bromine in basic conditions and aqueous acid. So again, these are called the haloform reagents, and we see that we generate this carboxylic acid intermediate. Then to get this final product, we can use, if you recall, thionyl chloride, SOCl2, to generate, instead of the carboxylic acid, our acid chloride. All right, now let's take a look at part C. The starting material here is now an acetal. We can treat this with aqueous acid to convert it to the ketone here. So in this first step here, we're just going to use hydronium. Any old aqueous acid will do. We generate that ketone intermediate. Then to get to the carboxylic acid shown as this is actually our final product here, but drawn out, we'll use the haloform reagents once again. Could have saved a step and not drawn out the final product, but that's okay. We see here bromine, sodium hydroxide, and then acid workup. So we have that carboxylic acid there. All right, now in part D, our final product, we can form this in with our first step here. If we react our starting amine here, so this is an amine, starting material, with aqueous acid, we can convert this to a ketone shown. So we'll hydronium here. Now we can react that ketone using the haloform reagents once again to generate our carboxylic acid intermediate. So we have Br2, sodium hydroxide, and then we have that acid workup step. So now we're going to move down below here because there's actually another intermediate. So we can now generate this second intermediate here using thionyl chloride like we did previously. So we take that again, carboxylic acid to make the acid chloride here. Now in this final step, if we treat an acid chloride with excess ammonia, if you recall, we'll see this reaction here where we can create an amide final product.